Hello everyone, my name is Mihaela Ștefan. I am a professional services engineer at InfiNet Wireless. Thank you very much for taking the time to join our webinar. Today we are going to discuss about the diagnostics for the InfiLINK XG and InfiLINK XG1000 devices. Let's briefly check the agenda of the webinar. We will first review the main parameters that can affect the throughput value and the wireless link quality. Then we will see what are the best procedures that should be performed before installing the devices in order to ensure a proper functionality. In the last section, I'll walk you through 3 typical scenarios where troubleshooting is required. I will actually show you how to practically perform troubleshooting from the web interface by following the procedural steps used in case of a complete technical analysis. Generally, the radio link quality depends on 2 factors, the configuration of the device and the external conditions like the precision of the installation, the environmental factors which relate to the emission, propagation and reception of the radio signal, and to many other aspects. The influence of these factors is quite complex and unique for each setup. However, during this webinar, we are going to focus on the configuration of the devices, more precisely on the parameters that influence the radio link throughput. The modulation and coding scheme parameter is a very important one because the throughput is directly related and correlated with the modulation level. The InfiLINK XG and InfiLINK XG1000 support 11 modulation schemes from QPSK until QAM256 and QIM1024. High-order modulations can improve the channel performance in terms of throughput. However, those can be used by channels having a corresponding high fade margin. An important feature in this sense is the maximum transmit power at high modulations, which is up to 26 dBm at QIM256 in case of the InfiLINK XG, and up to 22 dBm at the same modulation for the InfiLINK XG1000. The InfiLINK XG and XG1000 devices support the automatic modulation control feature. There are 3 available modes: conservative, which assumes using higher CINR thresholds in order to minimize the error rate; aggressive, which lowers the thresholds in order to use higher modulation levels and thus increases the throughput as well; and normal, which represents a balance between the error rate and the throughput value. Another key parameter is the frequency channel width. The radio link capacity can be increased by using a higher channel width for data transmission. However, each time we double our channel width, we also double the amount of noise. Last, we'll discuss the influence of the radio frame duration. A longer time frame implies less overheads and higher throughput, but if you aim for low latency values, shorter frame sizes are the best option. Therefore, you should bear in mind the balance between throughput and the quality of the transmission in order to optimize the configuration of your specific needs. In order to obtain the desired throughput and ensure a reliable device operation, the following actions should be performed before installing the device. First, make sure that line of sight is provided before the installation of the antennas in order to achieve the best performance of your radio link in that specific environment. Surveys must be conducted to assess the level of interference and to identify the obstructions. The influence of the trees can vary depending on the season, so keep in mind that during spring and summer, the leaves can absorb some of the radio energy. Therefore, when installing during the cold season over forests and trees, try to achieve a higher fade margin. Also install the antennas as far as possible from other antennas, ensuring at least 2 meters separation. Next, you should perform a frequency spectrum analysis in order to determine the interference levels and choose a clear frequency range. These are very useful input data for the wireless link planning phase. And the InfiLINK is a link planning tool which allows you to design networks using InfiNet wireless devices for optimal deployment and cost effectiveness. It supports different scenarios based on terrain profile, distance, antenna height, transmit power, device models, and other factors. The output is an installation report that defines the parameters to be used for configuration, alignment, and operation. We'll now move on to the practical part of our webinar. In order to demonstrate the functionality of the Instant DFS feature, we have preliminarily established a scenario comprised of an InfiLINK XG link that operates in parallel with an interfering link. The goal is to see what happens when Instant DFS is enabled. For this, I am going to generate traffic through the interfering link using iPerf. The traffic is generated from the computer behind the interf slave device, and this will only create interference at the reception of the XG slave device, as you will see. In this direction, the direction that we generate traffic, the splitter allows the communication without introducing significant attenuation. Let's see what happens. As you can see, I am now connected on the XG master device, and we are going to test the Instant DFS feature. You can see in the status section that DFS is disabled currently. We are using a fixed frequency. Let's go to the radio section. Before talking about Instant DFS, we have to check the frequency channel grids, which are very important. If we use the default channel grid, it can take a lot of time, maybe up to 10 minutes, until the units scan the spectrum and initially select a frequency. So I suggest that we shrink the range. Let's choose from 5000 to 5080. Okay. You should also perform this operation for your devices because it is very useful in practice. You don't want your devices to spend a lot of time scanning the whole spectrum range. Okay, now I'm going to apply the settings, and those will be exported to the slave unit as well. As you can see, this option here that exports the settings automatically. We can now commit the changes. The units have synchronized. We go back to the radio section. As you can see, our frequency range is modified, and we can see this as well in the downlink center frequency. We only have 5 channels available corresponding to the range that we have chosen. Also, a new frequency is used. We are currently on the frequency 5040. Let's now enable Instant DFS. As you can see, automatic frequency selection is by default selected because you cannot use a fixed frequency with Instant DFS. And we are going now to export the settings to the other unit as well and hit apply to commit the changes. Okay, this process should take a bit longer because we have to wait for the other unit to receive the settings. Then the master unit will scan the spectrum, choose a frequency, and the slave unit must scan for the frequency that was chosen by the master unit. This is why we had to shrink the frequency spectrum, so it doesn't take a lot of time. We can see that the link is already established. Okay, let's wait a little bit longer for synchronization. We can go again to the radio section. Okay, we see that Instant DFS is enabled. Now let's check the instant DFS section. Here we can see that instant DFS already selected another frequency which it considers to be less interfered. It shows the 5000 megahertz frequency. We can see that channel availability check is constantly being performed on the other channels in order to evaluate the interference level. The next step is to see what happens when we change the frequency of the interfering link. We will use the same frequency for the interfering link, 5000. I will change it right now. Okay, for the slave also. Okay, we will wait for the link to establish, and in the meantime we should see that the master unit reselects the channel. So it is now scanning and it should reselect the channel because it will see the interfering link operating on the same frequency. It takes a little time, but you will see the change. What I also want to mention is that now the RSSI levels are very low, around minus 95 dBm. This is because there is no traffic running on the links, so this is actually the noise level that we receive. And some service data that increases the level on the frequency used by the interfering link. Okay, we already see that the slave device, which should be interfered, has an average RSSI of minus 86 dBm. So this is caused by the service traffic running on the interfering link. On the master device, we do not have interferences because of the specific of our scenario, where the splitters do not allow the communication towards the master. It introduces a significant attenuation in this direction. We should shortly see, okay, it is now changing the channel. As you can see, it has now chose to change the channel. It uses 5044 downlink and 5064 uplink. So you should remember that our XG units are hybrid FDD units that can choose different frequencies for downlink and uplink to ensure the lowest interference level. We have seen that the best channel is chosen in real time. I just want to show you that the interference level increases in real time by generating some traffic through the interfering link. Okay, you can see the traffic running. After waiting a couple of moments, we should see on the slave device, here we are on the slave device, we should see the RSSI increasing. It's already minus 83. In time it increases. So this is because traffic is running on this frequency. Okay, it will slowly increase. As you can see, it is now minus 80 dBm. And this is caused by the traffic that is running on the link. We will now go further to our next scenario that I want to introduce. Okay, let's now review the troubleshooting steps for the second scenario, where the expected throughput is not met. The first step is to check the settings of the unit. The main aspects that should be reviewed are the firmware version, the license, the last reboot reason, the rate limit and port settings, the CINR and RSSI levels, and the radio parameters of the link. Let's see how this is practically done. Okay, we are back on our equipment. Let's go to the, first of all, to the maintenance section. The first thing that you want to check here is the latest release. You should use always the latest firmware version. And if a newer one is available, you should perform the upgrade in order to benefit of the latest improvements and features that were added to the units. Next, you should check the current license, which is very important and affects the throughput. You should check for the maximum transmit rate to see if it's limited to the correct value. You should also check the channel width that are available, because as we already discussed, the channel width is directly correlated with the throughput value. And another important parameter are the power levels, because you should be able to use the necessary power in order to obtain a reasonable signal level at the reception. Okay, this should be all about the license. In this section, another important thing for troubleshooting is this part, the last reboot reason, which shows you if it was a hardware failure, a software failure, a power reset, or a manual restart, like we see in our case, because we restarted the units when the settings were exported. The last thing I want to discuss in this section is regarding the diagnostic card. You will see that after we perform the troubleshooting steps, you might not find the root cause. If this happens and all the steps were performed, you have to contact InfiNet Wireless and you have to provide the diagnostic card by clicking on this button. This should cover the maintenance section and the important aspects that we want to keep in mind. Next, we'll go to the switch section. First of all, the port settings are very important. You should check the administrative state of the ports. They should all be up. Next, we are concerned about the rate limit. Check if the rate limit corresponds to the expected throughput value, and if not, increase it or even set it to unlimited. Maybe it is best to set it to unlimited. And the last thing is the port mode. Maybe the other unit has a manual setting and one unit has auto. We recommend to set both to auto in this case for the best communication. Next, we have the connectivity matrix, which shows us the active connections between the ports of the unit, also external and internal. You should make sure that the communication is enabled between the ports that you are using. For example, if you click on this arrow, you disable the communication between the Giga Ethernet 1 and management interface. You can enable it back. So this is very important because you might not receive traffic at all if you have this path or this path disabled and you use them physically. And last in this section is the VLAN-based switching. If you are using VLANs, you should check that the VLANs are correctly configured and that traffic is allowed through that VLAN that you are using on the specific port. You see, you have to specify the port and the VLAN that it allows to pass. Okay, this should be all for this section. Next, we are going to look at the status section. Here we can check statistics for the interfaces. You can see here the packets, how many packets sent, how many errors. So this is very important to check the statistics and see where the problem might be. Next, we are concerned about the radio indicators, mostly the CINR and RSSI values. These are very important when establishing the modulation level and the cause of the problem. As you can see, we have good levels here. The CINR should be higher than 30 dB in order to be able to use high order modulation and benefit of an increased throughput. RSSI should be between -40 and -60, and we see here that our link is quite stable and good. What I want to mention in this section is the error ratio. Keep in mind that the InfiLINK XG devices analyze the transport block error ratio, so not the bit error rate. The automatic modulation and control feature checks the transport block error ratio, and as you know, each application has a specific demand for the transport block error ratio in order to function properly. If the threshold for errors is high, then the AMC algorithm will also increase the SNR thresholds in order to force the equipment to use more robust modulations, so lower order modulations, in order to reduce the error rate and allow a good quality communication, even if the errors increase on higher modulations. Next, what I want to say is that if you see, for example, a bad CINR level, this means that the interference plus noise is becoming high. It indicates the presence of interferences, mainly if the RSSI level remains the same and it is good, but the CINR is bad. It means that we might have interferences. And the next step in troubleshooting in this case is to check the spectrum analyzer. Here you can see that we have to specify the range that we want to scan. Let's use our specific frequency range. What is very important here is that you can choose which polarization to check. We will use dual to check both polarizations for interferences. Another important thing is that you should always try to first check the interferences on the remote device, because the conditions of interference might be different. Wait for it to finish and then click on the last snapshot to see the result after the connection with the unit is restored. In our case, I am directly connected to this unit, so I will scan it directly and we will not lose connectivity with it. Let's see what happens. So we are now scanning the spectrum for interferences without any actual traffic running on the interfering link. As you can see, our interfering link runs on the 5000 frequency. It's quite clear here. The levels are very low. Input level is -87. There are no interferences. We see some interferences on additional frequencies. Here, for example, the input level is -68. This indicates some interferences. Let's now try to generate again traffic and see if the test changes. Okay, we could try to change the frequency of the link. We can try to change it again. I will try to have it like this. Apply. Apply. Okay, let's go back. I think the link is re-established. I will see if the traffic is still going on. Yes. Let's stop the test and start it again. Okay, we obtained an interference here on the 5020 center frequency that we put on the interfering device. So here the input level is -77. It is no longer at the noise floor at -90, for example, like we see here. So these frequencies are not interfered. Here we have the noise level. You can see the values. And these are interfered channels. Okay. You should always perform spectrum analyzer and see where interferences are present and try to choose the best frequency for your link. Now, if you see that both the CINR and the RSSI are having bad values, then in this case it might be due to an improper alignment. So you should go to the alignment tool. InfiLINK XG allows you to easy visualize the antenna alignment of the devices. So we have here some important parameters. I will start the test and see what our parameters indicate. The RSSI, as we discussed, is the input signal level at the reception. So in our case, the level is quite good, it's -47 dBm. Next we have the CINR, which we already discussed, and crosstalk, which is a new parameter, and it should be less than -20 dB for a proper operation. It is very easy for you to perform the analysis, because all you have to keep in mind is that the green bar should be in the black area. When it is in the black area, the alignment is proper. So you do not have to worry about this aspect. But for example, if you have the green bar in the red zone like this or like this, maybe it is a small bar, a long bar in the red zone, then you should check the other parameters, the transmit power, the antenna alignment on site. So basically our link functions properly. The last aspect that I want to show you regarding the troubleshooting for the configuration of the device are the radio settings. Here we have some parameters that influence the throughput, as we already discussed, the channel width, and you have here the available options that should be present in the license file as well. As you know, if you increase the channel width, the throughput will increase. Then we have the frame period, where you can use the values between 2 and 10 milliseconds. As you know, higher frame sizes allow higher throughputs but increase the latency. Next, you should check the maximum transmit power. Okay, you should check the maximum modulation. You should see if you allow the device to use the maximum modulation, because if you have here maximum QAM 64, then maybe this limits your throughput. Maybe you want more than this. And another important thing is the short cyclic prefix. You can use a short cyclic prefix in order to overcome the intersymbol interferences, and this will also increase the throughput value. Okay, this should be all for the configuration part. Let's move on to the next step in the troubleshooting process. I will switch to the presentation mode. Okay, we are back. After the settings are verified, as we have seen, the next step is to check the units on site physically. For this, you should check the Ethernet and SFP connections, as well as the integrity of the cables. If you are using external antennas, the RF cables should be also checked. Next, tighten the connectors and check the antennas. And further, perform proper antenna alignment on site. If after the alignment the CINR level is still low, it indicates the presence of external interferences, as we discussed. Try to use another frequency if available, or perform a spectrum scanning on site. If you are unable to identify the cause of the problem, please contact the InfiNet wireless support team. It is necessary to provide us the diagnostic card, the antenna alignment test results using screenshots, photos with the installed equipment, and the coordinates of the sites. This concludes our second scenario. Let's move forward. Our last scenario reviews the case when no data is being transferred at all through the link. We begin as well by checking the settings of the units. Make sure that in the switch section of both units, the internal port mapping is correct and the traffic flow is enabled between the required ports in the connectivity matrix, as we have seen on the devices. Next, check the administrative state of the Giga Ethernet and SFP ports. Enable the port if it is disabled. If the link status is up but no packets are received, check the configuration of the equipment which is directly connected. In case of using VLANs, make sure that the VLAN configuration is correct and the specific traffic VLAN ID is allowed to pass through the required ports. Further actions should be performed on site. As earlier mentioned, verify the Ethernet and SFP connections as well as the integrity of the cables. If you are unable to identify the cause of the problem, you should also contact the InfiNet wireless support team, which is available 24/7. As we have already mentioned, it is necessary to provide the diagnostic card, the antenna alignment test results, photos with the installed equipment, and the site coordinates. This brings us to the end of today's presentation. Now, if you have any questions, please feel free to write them down and I will answer them one by one. In the meantime, we will just have a short break. Thank you. Okay, we are back for the questions. First of all, Nick is asking if the green column saying ready shows that the channel will change once the 300-second timer expires. This column that shows the ready channels informs you about the available channels that will be used when interferences are detected on the other channels. So yes, there can be more channels ready. One of them will be chosen after the timer expires to be used as the new frequency channel. Next, also Nick is asking about the RSSI and the occupancy. Here in the case of the XG device, we do not talk about occupancy. We only have visibility of the RSSI level. So when we have interferences, you should directly see an increase in the RSSI level for the specific frequency. It does not show you the occupancy like in case of the R5000 devices. If we used an XG or Quanta 5, if the RSSI would be constant as the air interface is running at 100% utilization. Yes, once the traffic is stable, you should see a quite constant RSSI level, but an increased level. So if you previously had a noise floor, for example, with no interference, if you activate the interfering link, you should see the RSSI increasing, of course. Okay, another question also from Nick. If we can see the difference between the corrected errors, retries, and uncorrected errors. A particularity of the XG device is that the chipset does not support the ARQ feature. We have no retries because the chipset does not support ARQ. When you see errors on XG, it always means uncorrected errors that will affect the data directly, as Nick is saying. Gerald Thomas is asking what should he do if the CINR is not above 30 dB. There are general solutions like we discussed. You should perform spectrum analysis and see if the frequency is interfered. So reduce the order of the modulation. Reduce the channel bandwidth in order to reduce the noise. So this way you will increase the CINR value. Next, also we are asked about the pulses. You should keep in mind that the XG does not support the pulse detection like we have on the R5000 devices. You now only monitor the CINR and RSSI levels using the tools that we have and the status section. So in the status section you will see the signal levels, and using the tools like spectrum analyzer and antenna alignment you can see what happens on the whole frequency range where you have interferences, if the link is properly aligned, and or if you should perform further actions. Next, Nick is asking if crosstalk is the same as cross polarization isolation. Actually, no. The cross polarization isolation is a parameter that is specified by the manufacturer. What is the difference between polarizations? But the crosstalk shows you what is the difference between the component that is sent on a specific polarization and the part of it that is received as cross polarization by the remote antenna. So it shows you what part of the polarization is incorrectly received. I hope this clarifies the question. Anyway, it is not the same as cross polarization isolation. For the spectrum analysis, if one of the polarization is affected, we won't have any values. No, you will have values. So as we saw, spectrum analyzer allows you to scan separately each polarization, or scan them both, and it will show you where the interference is present. You saw that when we have interferences, we have some spikes, and if you go with the cursor over the spike, it shows you the level of interference and the frequency where the interference is present. So you will have a clear indication of the polarization. If you have concerns, you can scan separately. For example, if you have concerns about the polarization, you can scan separately, one first for vertical, then for horizontal, for example, and you will see exactly where the interference is present, which frequency and what level of interference. Okay, next someone is saying that after the link is established, it observes that the RF interface drops packets severely. If you do not have packets dropped on the cabled interfaces, this should clearly be a problem with the RF interface. So you have to perform the steps that we discussed during the presentation. So check the signal levels, the interference level, the alignment of the antenna. You can check all this on the devices. Before going on site, you should already have an idea if the problem is related to interference, to bad alignment. You should also check the parameters. If you have dropped packets, the throughput should also be affected. You should use lower modulation. So check the license, check the transmit power. For example, I recommend you to, in this case, to enable the control boost feature, because it will double the power on the control channels, and you will have a better quality on the link. So try to enable the control boost feature on both devices, and you should obtain a gain in quality and modulation. For the TX modulation and coding scheme, what should we see in order to conclude that the link is good? You should see normally high order modulations. If the link is good, the modulation and coding scheme should be high. If you have errors, the AMC algorithm will always decrease the modulation, will increase the thresholds, force lower modulations to take over. Nick is asking if is there any way to avoid the commit changes timer. I'm not sure if you can get rid completely of the commit timer, but you can say OK, and if you commit the changes, if you hit the OK button, you do not have to wait for the whole timer. As you saw when I configured the devices, I waited shortly and then I said OK, but I'm not sure that we can get rid of the commit changes timer, because it should be hard-coded. Okay, I see that we have no more questions. So thank you once again for your time, and I hope to see you again during our next webinar, which will be about the Quanta 5. Have a nice day, everybody.